is a training company as well as a consulting company. We are a company that spends a lot of time doing both training and consulting, and a lot of crossover between these two. As a consulting company, we principally focus on the Azure space, the Microsoft space, and we do our architecture analysis and design. We do custom software development, debugging, performance, and database, and different things related to that. And on the training side, we provide two different kinds of training. We provide live training where there's an instructor with folks, where if it wasn't COVID-19, we would go to your facility and train you on premise, or we do that virtually now, with a lot of cases where we're doing it online through a live instructor meeting on a platform like Microsoft Teams or GoToWebinar or something like that, to have interactive sessions that way. And then we also have a on-demand training, which is done through our website, winnolikenow.com, which we provide a virtual type atmosphere where you can watch training videos, and that's as well. So that's kind of who we are. Let's dive right into what we're going to be talking about today, which is hub and spoke topology. I really don't have a lot of slides to go through. It's mostly going to be looking at this slide here, which is currently blank. So there's a lot of stuff that's going to be on the slide by the end of this presentation. But it's mostly talking about, this is just kind of a reference point. So if I'm talking about something in Azure, we're going to be looking at it on reference to this slide here, because all the things I'm going to be talking about in Azure will be kind of represented in this particular slide. So this kind of gives you a topology of how it works. So where does this all start? So with an Azure migration, we typically start with something that we have on premise. So by on premise, I'm talking about something that is not on Azure. So setting this up sometimes might be multi-cloud, where folks have a cloud that they're already using, such as Rackspace or AWS or Google Compute, or they're co-load in some kind of data center somewhere, and they think of that as not so much as on-premise. But for our purposes, I'm talking about on-premise as something that's not on Azure, something where the infrastructure is not maintained by Azure, rather it's by something external to Azure. And this is represented by this box here on the left, where I have an on-premise network. Now, the demo that I'm going to be using today, it uses an on-premise. The actual network I'm broadcasting this from is the network I'm going to be doing this from. So it's my office network. And in that office network, I'm using an IP space of 10.0.0.0/8, which represents all of the class B or really class A networking that you can use in the RFC specification for that. So that's the full space. I'm not actually using that much. I don't have millions of computers that are connected to my network. I just kind of have anything that starts with 10 dot. I know that's my local network, and anything else I put in Azure is going to start with a 172 prefix. And I'm using /16s on Azure. So that's my CIDR block down here. So if you're wondering what I'm referencing by all that, I'm talking about the actual IP space for my given network. So in this case, I'm using on-prem here, and then for my everything on Azure, I'm going to prefix with 172. Now the second octet will vary depending on the network that I'm talking about, but if it starts with 172, that's on Azure, and then 10.8 is over here on my on-premise network. So, and I'm going to create a network that connects these two together. Now, of course, this is going to be brokered by way of a virtual private network, or a VPN, or something called an express route. Now, most folks would be familiar with the concept of VPN. Now, there are different kinds of VPNs out there. There are what we call point-to-point VPNs and site-to-site, or what I might call point-to-site VPNs and site-to-site VPNs. Point-to-site VPNs are those kinds of VPNs that you might see advertised online or on TV, where you have privacy VPNs, where you install something on your phone or on your PC, and you connect to it, and it provides a private connection to that data center, wherever that VPN is, and then it appears as if you're originating on the internet from that point presence. So a point to site is me using one of those privacy VPNs on a personal device. A site-to-site VPN is the kind of VPN that we're using to connect two sites together. So in my case, my business network here and Azure. So we're going to be setting up a site-to-site VPN over Azure, or you can use something on Azure called an express route. Now, an express route on Azure is a high-speed connection between Azure and a data center that is brokered by a telco, and it works like an MPLS does. where it is a high-speed connection that might be multiple gigabits in bidirectional, and it traverses not the open internet like a VPN does. Rather, it traverses the backbone of a given telco's infrastructure. So it might be someone like AT&T. So if I set up a connection with ExpressRoute between Azure and AT&T, really what I'm doing is I'm saying my on-premise connection is brokered by AT&T, and AT&T also has connections into Azure data centers. And then when I set up that private connection here, I am able to set up the connection between those two using a fast connection that never crosses the open internet. Rather, it's a private connection between Azure and my data center that rides that backbone, and so it gets much better, much lower latency and better throughput than a VPN would. So ExpressRoute or VPN basically do the same kind of thing. Of course, VPN is going to be lower cost, but ExpressRoute is going to be higher performance and probably more reliable. And on your on-premise side, you typically need some kind of VPN appliance to make that work. So that's going to be your Palo Altos. That's going to be something like that, or a Cisco appliance or something like that. Or if you're using ExpressRoute, a piece of hardware provided by your telco that brokers that relationship back to the telco. And on Azure, once that's set up, once that's employed on the actual hardware on the on-premise side, you use something called a virtual network gateway on Azure. And a virtual network gateway is a tool on Azure, or really a suite of tools on Azure that is all about brokering these connections to on-premise. And it gives you the ability to do site-to-site VPNs. It gives you the ability to do point-to-site VPNs, and it also works for express routes. And with a point-to-site VPN, it gives you the ability to do it in a couple different ways through like OpenVPN, which is an open source VPN that is available for basically every platform out there. And then with, of course, with site-to-site VPNs, you can use something like IPsec, which is a protocol that is useful for setting up VPNs for site-to-site. That is an open standard, so it can be implemented by any number of different kinds of vendors. In this case, Microsoft can implement it, as well as Palo Altos or a Cisco appliances or Fortinet, whatever it might be. And you can use those because they implement the standard. They will talk to one another. So let's switch over to Azure and then look at the virtual network gateway, and then look at the connection that I have set up here for this to set up this what we call hybrid connectivity between an on-premise network and my virtual network here. Let's go flip over to Azure, and let me pull that up right here. And here is the resource group that I have set up for this in Azure. So I'm in the Azure portal at this point, and I have all the things provisioned already, mostly because some of these take a while to set up, like VMs do, and as well as the virtual network gateway. The virtual network gateway in particular does. And so if I come down here into my virtual network gateway, it's this resource here. I call it my virtual network gateway is VPN to on-premise. What I have is the ability to connect it through a different kinds of connections here. So if I use user VPN configurations, this is for that point to site configuration here. This is like you see here with point to site. Let me blow this up a little bit. Point to site configuration, and that's for those Road Warrior VPNs that you can actually use on Azure, and you can configure this to use the built-in VPN client, or you can use OpenVPN as well. I'm not interested in that for hybrid connectivity. I'm more interested in this configuration here, which is my site-to-site VPN connections. And for this one, I'm using a site-to-site IPsec tunnel. And for this particular one, what I did is you can provision what you need to provision this is the virtual network gateway, a public IP address that's associated with the IP address. So that would be 168.162.77132 right here. And then you need something called a local gateway. Now, a local gateway is another resource that you have to define in Azure. And what the local gateway does is basically defines the resources that the IP spaces that are on your local network. So if I come down here to my configuration, I'm telling it what is my public IP address. So if I do, that's my current IP address. So if I drop my connection and it reconnects, I'm going to have to reconfigure this. But it's the IP address from which the VPN connection would come to. So if I go to what is my IP, you should see that same IP address right there. So that's my public IP address. So if you want to do a DDoS attack against my network, there's my IP address. And I'm putting that into Azure right here as the place where I'm connecting from. And then this is also where I specify the address space for my local network. And I am telling it I'm using this 10.0.0.0/8, which is a rather large address space. I'm not even using a fraction of that. And I'm telling it that's what I want to use. If I configure BGP right here, which is a broadcast gateway protocol, what that gives you the ability to do with BGP is it allows you to have routes configured by a device on premise, and then it will send a configuration over across a VPN or over across a MPLS or over across an express route to Azure, and then Azure will do the same. And what that does is it has all the routes for your on-premise connection broadcast back to Azure, so you don't have to manually add all of those routes back into Azure. Rather, those get put into Azure, and then those show up in whatever it is that you're connecting back into Azure. So the configuration of this local network basically tells the VPN configuration where to connect to, where the connections are coming from, and what's the address space that I'm going to be using. Now, with my site-to-site configured right here, I have a share key, which I put in on both sides, and mine is super secure. I'm not going to show that to you. That's what I configure on. I'm using a share key. You can also use certificates, but I'm using a share key here, so which I put in a share key on one end and a share key on the other, and then it uses that to encrypt the traffic across the VPN. And so that allows me to have a secure connection between these two endpoints. So once I have that configured, what I need to do is also add it to a virtual network, which in this case I'm calling it, the virtual network is called Hub VNet, which is a VNet that I configured that has a couple of subnets in it. One of them is dedicated for my gateway, which is that virtual network gateway, and then this one right here is if I wanted to put some kind of shared resources in there, which is a very common thing to do. So a Hub VNet is the one that you want your gateway to be connected to. So your virtual network gateway or your express route is always going to come into this hub, and then we will actually build the spokes off of the hub when we talk about those in a moment. But the virtual network gateway is the principal component for connecting ExpressRoute or VPN back into Azure. And I've configured, rather than configuring an appliance to do this, I have configured down here I have an RDP session, not RDP. I've configured a virtual machine to connect back to Azure using routing and remote access services in this virtual machine to set up an IPsec tunnel, rather than configure my firewall, because this is not something I intend to keep around forever. It was something I built for a demo, and this is a VM I created for this purpose. So what this VM has on it is the ability to connect to that, and I have routing and remote access services. And so to show you what that might look like, if I come down here to command prompt, and to show you that this is connected, I can do a route print, and this will show you that I have routes configured for the on-premise type connections back onto Azure. So here's that I have 172 through 116 right here. That's configured for broadcasting things back onto Azure. So anything that's kind of in that subnet, it will push out to that, as well as other things that are on that same interface. This one right here, this one. And so you can see that's my route table right there for configuring those routes back onto Azure. Now that's because I'm connected to that particular IP space over there. If I wanted to ping that, if I wanted to connect to a virtual machine over there, I can come over here and look at one of the ones in my other VMs that I have in my spoke, which we'll look at in a moment, and I'll ping that in a moment. But that's showing you that I'm using routing remote access configured to connect to my virtual network gateway, which you can configure any appliance to do that, or a virtual machine like Windows Server in this case. And if I come in here to that connection, it should show that I am connected as well, using that site-to-site IPsec tunnel back to back to my on-premise network. So that's the first portion, using the virtual network gateway. Once I have that established and I have that gateway subnet set up, the thing I want to configure then is the next piece of this, which is going to be these spokes. Now, a spoke VNet is a VNet on your Azure infrastructure that is a separate Azure VNet. Now, a Azure VNet that acts as a spoke is intended to house some kind of functionality. It can be in this different subscription in the hub, and it has its own address space and its own subnets, and it has its own virtual machines, its own resources, and it is connected back through to the hub by way of something called VNet peering. And VNet peering is a technology that Azure embedded into the Azure ecosystem to allow you to essentially connect two different VNets together that have a private tunnel between those two VNets across subscriptions, across regions, and this allows that traffic to flow more or less seamlessly with the routing being brokered by Azure, so you don't have to stand up a bunch of special routing for traffic to flow between this VNet, say right here, and this VNet right here over this connection, this VNet peering connection right here. The main thing that you want to be careful about, though, when you set these up, these VNet peerings, is to make sure that you don't have overlapping IP spaces. So in this one, I'm using a 172.18/16, which does not overlap this one down here. And likewise, if I had another spoke over here, I would have a VNet peering down here that has a different prefix, in this case 172.20, without an overlapping, that's not overlapping either the hub or this other spoke over here. So I have one hub with two spokes in this particular diagram. And this particular diagram, I only have a single subnet within each of those spokes. And of course, my space here for this one would allow me to have a lot more VNet subnets to find inside of this VNet right here, as well as down here, since I'm only using a /24 and a /24 for the one subnet that I have defined here. So let's go look at these VNet peerings and see what these look like inside of Azure. So I'm going to flip back over to Azure and look at these VNet peerings again here. So back in my resource group, let me zoom out here. I have defined here a couple of VNets inside of this particular resource group. There's my hub VNet, my spoke VNet, and I'm going to come down here and to my hub VNet, and this is my virtual network gateway here, which you've already looked at, and then I'm going to look at my peerings, which are right here. So with a peering, the peering is what you set up to connect those different spokes back into this particular VNet. And if I go into the configuration here, what I want to make sure that I have set up here is the ability to have a couple of things turned on so that traffic will flow seamlessly between these two. So when I set this up, I've got to know what the remote VNet is, as well as the local VNet, and that's defined by a resource ID. If these are in a different subscription, you would need to know this and initiate it on both sides. However, if you're on the same subscription, or you're in the same, if you're on a user that has access to those subscriptions, then you can set this up right in the portal without having to know that VNet ID. You just simply need to figure out which subscription the VNet is in, and then it will figure out whatever that resource ID is. However, if they're in separate subscriptions that you don't have access to with the same user, you would have to get that remote VNet ID from both sides and plug it in, and then initiate it from both sides using two different users to do that. But once you have that remote ID and that peering is set up, you can then on both sides, it will automatically peer those for you across Azure's backbone. But in this case, I had access to both of them, and I was able to configure them rather easily. And then once you have those VNets figured out, you can come down here and check some of these options. What you want to allow is allow a virtual network traffic from the hub to the spoke. You want to allow the traffic to go from the hub to the spoke, or from the spoke to the hub. So you want to allow it for both. Forwarded traffic would be things like routed traffic from on-premise back into the hub. So what this allows for is allow forwarded traffic from the spoke VNet to the hub VNet, which would be basically transient traffic from both sides. And so that allows for traffic to traverse a network as well as originate from that network as well. And then gateway transit is something you want to turn on the hub if you have a VNet virtual network gateway attached to it. And the gateway transit is what allows traffic to flow across a spoke VNet across the hub VNet into your on-premise connection. And so that gateway transit is needed so that the traffic can be routed across those different VNets. So back in Azure, if I was going to set up a new one of these, I can simply come down to peerings and click add. I don't have another VNet to add to this, but you would. So I know my resource ID, and that's where you can plug that in, or you can choose subscription in the virtual network, and then give it a name. And if it's from the other side, if I wanted to look at this from the other side, from the spoke VNet, I can come down here to my peerings on this side, and I can look at this peering going back the other way, and notice it says use remote gateways, and this is so that it tells the spoke to use the remote gateway on the other end. That's the virtual network gateway to send traffic across the hub VNet back to that remote gateway, so that I can allow traffic on this VNet to be sent back to on-premise. And that way, all the traffic flows smoothly and nicely across my VNet, and everything will work well that way. So once I have these peerings set up, then I should be able to connect from an on-premise virtual machine or on-premise machine to some resource in that spoke. So to demo that, what I have here is I set up a couple of VMs here. One of them is called Spoke 1 VM, and Spoke 1 VM is just a simple Ubuntu server that is connected to my Spoke VNet. And this one is Spoke 1 VM right here. And if I come over here to its networking, it's on the Spoke 1 VNet on the default subnet, and here's its private IP address. And similarly, on the same token, I have the same basic configuration. I have Spoke 2 VM, and it is on Spoke 2 VNet on the default subnet. So it's got a different IP address. The other one had a 172.18.0.4. The other one has 20.0.4 for its IP address. So again, similar IP addresses, but basically the same kind of VM on two different spokes. So I should be able to reach those from my VM here on my virtual machine here. So if I do a SSH tunnel from this, so to show you that this is running locally, this is my local IP address here. So this is on my local network. And then if I do a ping against say 172.18.0.4, I'm going to get ping traffic back. So I'm able to communicate with that one. And let's do a 20 to show you that one's connected too. So that's routing there. So let's do an SSH tunnel into one of these. And let's just do 172.18.0.4. And let's give it a password. And this should pull up an Ubuntu session here. Notice that it says last login was today. It's I guess from this IP address, the previous update. So again, I'm logged into this. I can run commands against this guy. I can do sudo -i. I'm in that virtual machine. I can do app.get update. To do updates on this VM, whatever. But this is not a publicly accessible VM. So again, this is going across my VPN, going across that virtual network gateway. The routing is then being traversing that hub VNet and then coming back into that spoke. So it's asking me to download Java. Let's go back over here and look at the deck. So I was basically connecting from, say, this VNet here, and then the traffic was going across my VPN, across that virtual network gateway up here like this, traversing that VNet peering, coming across the subnet and coming back into this right here. for that SSH tunnel. And if I was to connect to the other one through that VNet peering, it would be the same basic concept. I'd come back down here, and then it would come across there back into that VM as well. And so that particular pattern is how this is going to work. So if I come back over here and look at my machine here that is trying to update Java, and I do exit, I might be able to do a trace route to that one, that IP address. Let's do it to 0.4 and see if that actually will give me a trace here. Trace route. Oh, I'm on my VM. I'm not on still on my VM. Let's do trace route 172.18.0.4, and let's see if that will actually trace. It's probably going to give me, I've never actually tried to do this. Let's see if it works. And it should hit the external, should hit the hub. And oh no, it just went straight there. Okay, it didn't have to route at all. So that's good. And it just basically traversed that VNet without actually doing any additional hops. So that went right to it. So again, this isn't routing. This isn't doing any kind of smoke and mirrors. There's no port forwarding or anything. It's just straight up packet routing at this point. So let's look at one other thing that will relate. And this is kind of a new thing that Azure has added in recent months, I guess. VNet peering is an older technology. VNet virtual network gateways have been around for a while in Azure, but the Azure will have added in the ability to add platform as a service services into Azure VNets so that you can access those platform as a service resources across a private network. And they call that functionality private link. So let's go and take a look at what that might look like. And let's go back to the deck here. And so back here on the deck, let me get rid of some of this garbage here. Let's get rid of erase all ink on slide so that we get a little cleaner here. There's something called private link, and private link is a feature that Microsoft has been really working hard to get available to more and more platform as a service offerings on Azure, such as SQL Server, as event hubs. They're trying to connect to Cosmos DB, basically any kind of database that you have on Azure, be it Azure SQL or be it one of the open source databases like Postgre or MySQL or Cosmos DB with its APIs, or some of the messaging platforms like Event Grid or Event Hub or Service Bus, or some of the other things like Batch, Azure Batch. Beyond the typical VMs that you would connect to a VNet, they're allowing you to connect these kinds of resources to your subnets by way of private link. And so what this ends up doing is gives a SQL database right here a private endpoint on my my subnet here. So it will get its own IP address on my virtual network here. And so what this will have is an addressable IP address that I can then basically do the exact same thing I did with that SSH demo I just did. Across my tunnel here, come across my VNet peering back through my VNet and across my subnet to a platform as a service offering, which is a SQL database, rather than going out to the public internet to access that exact same resource. And that is a way of providing extra layers of security on top of the already encrypted traffic across a connection onto a SQL platform. It also reduces the attack footprint for a given a SQL resource or a different platform as a service resource that you might have connected to your resources that is not publicly exposed by way of a publicly accessible endpoint. Therefore, the attack surface is much lower, and I can only access it by way of a VPN this way. And that way, I can ensure that as long as the more secure my perimeter is, and the more secure that those resources guarded by that perimeter are. And so this is no longer on the perimeter, it's internal. And so I'm securing it by way of a lot of different technologies to secure a private, particularly data. That's the one that you want to guard the most, and in such a way that it will make sure that my data stays guarded as well. So let's go back over to my my virtual network gateway, and not my virtual network gateway, my resource group here, and look at my SQL endpoint here, I have defined in here a SQL server and a SQL database. And if I come over here to my SQL database, I will have inside of this right here, I have the ability to create private endpoints as well as the, if I come over here, where is, find it. Maybe it's on the, I think, sorry, it's on the server. There it is, private endpoint connections. And this is where I set up that endpoint on my Spoke network. And what I did here is I said, I set up a private endpoint here. And this one is called Spoke DB endpoint. And it's basically providing me a private endpoint for the logical server here so that all the databases on this are only privately accessible. And I configured the firewall to block all deny all public access to this particular incoming, all the public access coming into this particular SQL server. And I do allow a client IP address if I wanted to connect to this. That's my local IP address here. But if I wanted to disable that and only allow my LAN to come in, that is going to be this particular range of IPs address here. And so the firewall's there. I have a private endpoint. So the security for this is configured in such a way to only let my stuff from my private network come into it. Now, what I did, now when I set these up, it's going to show up as a private endpoint on my virtual network here. And this is the endpoint it created. It's called a private endpoint, and the technology is called private link. And it's connected to a given virtual network here. So it's on Spoke 1 VNet with the default VNet, and it shows up here. Here's this IP address, and I can get that as part of my IP address space within my Spoke VNet here. And now that's got a private endpoint, I can access that. Now, the one caveat for doing this, though, and I will say this, is it requires that you have a DNS solution to resolve these IP addresses to the names assigned to whatever the logical server would be. And so if you did this with something like a storage account, because Azure uses the name of the storage account to reference the actual resource on Azure, that has to be a part of the request that's being made by whatever SDK or whatever client you're using. And the same is true with SQL Server. I can't just use the IP address. I need to be able to tell it what name. So I have to create a DNS solution to enter into that the name of the particular database that I have configured, or the storage account, or whatever it might be, to connect to that. I can't just do it by IP address. So this particular SQL Server is called Spoke 1 SQL Server Database Windows.net, and that's the thing I need to put into my DNS records in order for this to resolve. Now, there's a couple of the Azure ways to do that. You can use what they call a private zone file, which I don't have created here, or you can create a DNS server in Azure, put that up into your hub, or you can maintain that on-premise. And that's the option I chose to do with this one, is I had to have an on-premise DNS server configured here. So if I come down here and open up the DNS, I have my DNS server defined a record for my particular DNS record for my SQL Server defined right here. So Spoke 1 SQL Server, and that's pointing to that 172.18.05, and that's the zone is database.windows.net. And so this will allow me to use a local client here to resolve the name to that IP address, so that it will allow me to connect to it. So that's a caveat emptor for using private endpoints, is you have to figure out that DNS solution. There's a lot of ways to do it. I'm just using this one. You can use private zone files. You can use a DNS server like I'm doing here, private, public, whatever it might be. As long as it resolves to this IP address, I'm golden. And then, so to show you that this works, I can launch SQL Server management tools. Let me give this a second to pull up. And then I will connect to it. This particular machine I'm running this on has a fairly slow drive, so stuff doesn't load really fast on it. But as soon as this does come up, I should be able to enter into some credentials and log in. But while we wait, there it goes. So there, I pulled it up. So I must have connected this already, and I've got the credentials already cached, and And then once I have that connected, it's now resolving to that local IP address, and I'm connecting to it by way of the database. And there's that Spoke One database, and this is the database, and with all the tables that it has in there. And this is just sample data that I chose when I created this particular database. I asked it to put in the just the sample data for this database. And if I select, this particular table, select top 1,000 rows, it'll pull up those rows. And I should see, data being pulled across my my VPN here, and that's all traversing that network using that sample data. And to show you that that's not a bunch of smoke and mirrors, I can just do a ping to that, or it's not going to ping back, but it should get you the IP address right there, so that I am resolving that IP address to the local IP address on Azure. It's not local to me, but it is a private IP address. It's not the public IP address for that particular resource on Azure. So private endpoints are our new feature. Again, those are one way to set this all up on Azure. So let's go back to the deck and make sure that I have covered everything that I want to talk about for setting all this up. So just to recap, let me get rid of the ink here, and let's see if we can erase all ink. Now, just to recap what we've talked about VPN appliances and express routes and VPNs there. We talked about virtual network gateways and how to set those up. We talked about express routes and VPNs on Azure, point-to-site and site-to-site VPNs, and how you would go about using those. And then we talked about Hub VNet and creating that. We talked about VNet peerings, and we talked about how to set those up. And we've talked about private link for platform as a service resources on Azure. And we talked about virtual machines and connecting those up to Azure and then having all the routes. The one thing I did not cover, and that's because I didn't have something to set up for this, because it's really expensive for a demo, is to set up what we call a transient network for VNet to VNet communication across what we call a transient network. So in this case, if I wanted traffic from Spoke 1 to communicate with Spoke 2, I would have to put something inside of my hub to route that traffic accordingly, because Azure's not going to do that automatically. It doesn't. You can have the transient network have that traffic cross that network, but it's not going to automatically route that for you. And so to do that, I would have to set up a network virtual appliance, such as something like a Palo Alto or something like that, or I would have to stand up a Windows firewall, an Azure firewall inside of this hub right here. And because the Azure firewall is an expensive resource, it bills it by the hour. I would run out of money real quick inside of this little subscription that I have on Azure to set that up. But once you have that set up, what you can do is you can set up rules and routes inside of that firewall to allow traffic from spoke to spoke to to traverse this hub network and communicate with one another. Or if you wanted to solve this more directly, you can also peer these two networks together. However, I don't recommend doing that for larger deployments. And the reason why is because maintaining all those peerings can get rather arduous. It's better to actually have another spoke that acts as a transient network, and then use a transient network to have the traffic go something like this, rather than having it go directly, having it going more across that transient network rather than having a direct peering like this, because maintaining just umpteen thousand peerings can get rather arduous if you go down that route. It is possible. It's not a recommendation though. So just something that you might want to consider if you have a lot of spokes coming off of your hub VNets, or it might work for smaller deployments, but for larger deployments, not a best practice. It's best practice is to use a transient network. So that pretty much covers everything that I have for this. I will take questions now if you guys have some. It looks like there's already some. You can pose those in the questions box pane over here, and I'll look at those and see what questions we have inside of here. So there's just two questions at this point. Please post those in there if you have those, and I will answer these in this live question and answer session. So two questions that have been posed here is one, If you want spokes to communicate with each other, would you peer the spokes together, or is something else? I just explained that. Well, that's good. Is there a best practice? Exactly. The best practice is to do the hub transient and then have a network virtual appliance inside that hub and have it do that route to between spoke one and spoke two to go across that hub. So if you wanted to do that routing, that's the best way to do that. That's the best practice rather than do a direct peering between them, because maintaining peerings like when you get triangular type peerings going on, as you grow your network, those become more and more difficult to maintain. So it's best to have a transient network to handle that, and then go from there. Question number 2 is, what's the reason to have greater than one spoke? For mine, I'm guessing that for a hub and spoke topology, the idea of having multiple spokes, there's a lot of reasons you might want to do this. One is, if you're an enterprise, it's a good way to get isolation between applications or a business division. So say I had like a application that was a set of VMs. So I have 10, 15 VMs in that application, and I want to provide some isolation from another app that is on the same network, but they don't really have anything to do with one another. And so I would have a hub for application 1 and a hub for application 2, and then I would use the isolation that those have in their VNets to isolate those so that there's no crosstalk between those two guys. And the hub gateway, I'm sorry, the hub VNet would have things like shared resources such as a domain controller or a DNS server, or in the case of traffic flowing between those, some kind of routing device that would allow those to traverse there. So that's the idea of having the greater than one network. I thought I saw a ping from spoke 1 to spoke 2. No, what you saw was a ping from you saw me pinging I think you saw me ping from on-premise to my spoke 1. That was crossing my VPN going into my local. So to show you what I was talking about there. And maybe I did do that from spoke 1 if I did set that up. Let me pull that back up and make sure I verify that I did do that from my ping was from spoke 1 here. Let's see, where did I do that ping at? Yeah, that's where I did the ping, right here. I did that from my local box here, which is on my host, back into Azure. So that was pinging from 10.0.0.2 to 172.20.0.4, and that ping was traversing my VPN and then my hub back into my spoke, and so that route was following that route there. So that was what that ping was following there. So I saw a ping from spoke 1 to spoke 2. So to have a ping from spoke to spoke, I would have to have that transient network set up where I have a virtual network appliance installed on that hub, and you can do it with Azure Firewall as well. You need something that will actually handle those kinds of routes, because it's not something that Azure is going to do out of the box. It requires to have that NVA out there, and it would require that you have probably a route table in each of your spoke VNets to send things to that NVA, and then the NVA would be configured to send forward those onto the gateways accordingly for the given route. So just some things to consider there for different kinds of traffic that you're trying to set up there as well. So that's all the questions I see here. So if that's all the questions, I don't see any more questions coming in. So with that, I think we can call it a wrap. Please do check us out online. You can check us out at www.wintellect.com. And for more information about consulting services and training options, you can also follow me online on Twitter at the One Mule, and you can check me out. If you have any questions, please feel free to email me at bstewart@wintellect.com. And I post a lot of stuff about Azure on my Twitter account, and we constantly have a lot of stuff going on with Azure related stuff, webinars and white papers and blog posts and videos and a lot of other additional training content that we give away for free on Wintellect. So it's just a way to get good information about Azure. So please do follow us there, and check us out on winterlike.com. We also have a YouTube channel with a lot of videos on there related to Azure related topics. And if this is your first Winterlike webinar, I hope to see you on future ones. If not, thanks for coming again. And we'll be posting this on our YouTube channel, the recording of this webinar, so you can check it out for future videos, future reference, if you so choose. So thanks for coming, and hope to see you soon.